Hello everyone. Hello, hello. Like afternoon we met our atoms nucleic chapter or lecture. All right. I think my voice is audible. If it isn't, let me know in the chat box, people. Right. அதான் கேக்குது. Okay. Do smash the like button before you join this video. இன்னைக்கு கொஞ்சம் லேட் ஆயிடுச்சு. I had a class நடுவில் after this one. So, okay. Hi. There are people who are watching and they still don't say hi. It's hello, Muthukumar. Hi, Muthukumari. Hi. As usual, let's ask me about your how your preparation is. Okay, let me know how your preparation is going on, people. Okay, இன்னும் வந்து 23 days தான் இருக்கு. Okay, fine. This will last for like 10 minutes. அதுக்கப்புறம் we'll take class. Okay, I'll start with magnetism and matter. Okay. I'm start today. I will crack a neat. Hopefully you do. If you start it today, 23 days tarke. Just uh, just get reminded that there are people who have already started. Okay, well, like 20 lakh people who have already applied, who have applied for this exam, and majority around 13 lakh people would have already started their preparation. So you're lagging behind 13 lakh people. Keep that in mind and if prepare. Okay, fine. Hi Safura. Hello. क्या हाल चाल? Everyone, yeah. So, if you see, cracking an exam could mean different. I mean, it depends upon perspectives of people. If for me, cracking an exam meant that I got the college of my dreams. Okay, they on there for a few people it might be just a government medical college. For people it'll just be clearing NEET examination and being eligible for counseling. Okay, right. Okay, Virat Kohli is here. Hello. Yeah, Nisri. Hi. எல்லாரும் எப்படி இருக்கீங்க? How are how are you guys? உங்க மென்டல் ஸ்டேட் எப்படி இருக்கு இப்போதைக்கு? I got 695. But how many mock test is enough now? Every day I did 2 mock tests. I think 2 mock tests will be fine. ஆனால் இப்போ தான் எந்த லெசன் படிக்க போகிறேன். ஸோ இந்த லைஃப் போதுமா? இப்போ தான் இந்த லெசன் படிக்க போகிறேன். திஸ் லைஃப் will be sufficient for you to know the concepts and I'll solve questions. ஏன்னா இந்த சாப்டர் ஒரே ஒரு சாப்டர் தான். I mean I'm taking only one single chapter in this lecture. So yeah, ஏதோ பரவாயில்ல. ரோஹித் CR 7086. Yeah, it will be sufficient. stressful. Okay. Well, it's an exam which decides what you're going to do in your life for the next 5 years. So it should be stressful இல்லையானா தான் பிரச்சனை. Okay. Tips சொல்லுங்க அண்ணா. For what? uh, Physics or general or whatever. உங்கள் லைஃப் பற்றி உங்கள் லைஃப் எப்படி இருக்கலாம். I'm looking forward. நல்லா தான் போயிட்டுருக்கு. It's going good in MMC. ஓகே, கிளாஸ் ஆரம்பிச்சிடலாமா? ஃபிசிக்ஸ் டிப்ஸ் சொல்லுங்கண்ணா. இட்ஸ் வெரி blunt. Just practice, in my opinion. Just practice questions, okay? அவ்வளோதான். Okay, sir, start பண்ணலாம். Okay, fine. I'll start then. If you have any queries, still ask me, okay? About your preparation, how to do, because I had few seniors who helped me in the time lab. Okay, 1 month gap I used to call them, and they are my seniors now too. And அதோட இட்ஸ் வெரி இட் வாஸ் வெரி ஹெல்ப்ஃபுல் அந்த டைமில். அதனால் ஐ ஐ ட்ரை டு பி சச் அ பர்சன் டு பீப்புள். ஸோ if you come here, I'll be really happy, right? Yeah, so okay, so if you still have anything you want to talk about your preparation, about how it's going, how it's not going, whatever you want to do, you're not able to do it, anything, maybe, because like next 23 days we have to be complete peaceful state of mind than too much stress இருக்கும். பட் அதை ஓவர் கம் பண்ணுறதுக்கு I will do my best to help you guys. Okay, fine, paka. Okay, I think I'll start the class now. I studied 12th physics and but 11th half portion complete. Is this enough? It could be enough for getting decent colleges, but அதுவும் வந்து நீங்கள் எவ்வளோ படிச்சிருக்கீங்கன்னு பொறுத்து தான் இருக்குது. ஹவு இன் டெப்த் மார்க்ஸ்க்கு எந்தெந்த சாப்டர்ஸ்னால் மெக்கானிக்ஸ், அதாவது இட் இன்க்ளூட்ஸ் லாஸ் ஆஃப் மோஷன், ஒர்க் பவர் எனர்ஜி, system of particles in rotational motion, mechanical properties of fluids, mechanical properties of solids, and gravitation. இந்த 6 சாப்டர் மெயின். அதுக்கப்புறம் current, electricity and magnetism entire unit ஃபுல்லாக 2. 3 will be your ray optics, wave optics. Okay, 4 is your modern physics. I think இதிலே வந்து you will get for இதிலே வந்து you will get a sufficient marks. I mean 100 marksக்கு questions இருக்கும். இதிலேருந்து கேட்டுருவாங்க usually. Fine, okay. Alright, fine. Let's start, okay? For those who don't know me, this is Rihan from Madras second year MBBS from Madras Medical College, here to take magnetism matter in this crash course of ours. Okay, fine. All okay. This chapter, in the chapter we discuss about magnetic properties direct. We are not talking about field strength about adala. We are talking about general magnetism. Okay, fine. Okay, bar magnet as a magnetic dipole. Okay, fine. We know in an electric dipole we have a positive charge, a negative charge, separated by some distance. Okay, fine. And they are not even in contact. Okay, this is what an electric dipole is. And then magnetic dipole பார்த்தீங்கன்னா a bar magnet. Okay, it has two poles, north and south. I don't know which one to denote north, which one by south. So say north and south. Okay, it's my notation might be wrong as well. Okay, but still, I think this works. In the north pole, and there will be magnetic field of line emerging out and going into the uh, south pole, and then they inside the magnet they go from south pole to north pole. This is how the field lines move. Okay, fine. இந்த மாதிரி இருக்கு ஓகேவா in bar in an electric dipole they are separated by some distance. So correct. Okay, they are separated by some distance and there is nothing in between them. Okay, also they are not in contact. இங்க பார்த்தீங்கன்னா they are in contact. Okay, this forms field lines which are not closed, but magnetic field lines are always closed loops. அது எல்லாருக்கும் தெரியும். Fine. And okay, this is what. So we are considering our bar magnet as a magnetic dipole. Okay, fine. Now in the magnetic dipole, good magnetic dipole moment கண்டுபிடிக்கலாமா? Fine. Okay, nice. So it's nothing but my pole strength M into length. Length is nothing but L எடுத்தா it will become L by 2 in few expressions. So we are taking it as 2L. Okay, so taking this entire thing as entire length as 2L M into 2L. Okay, wow. This L is nothing but my magnetic length. Okay, ஏன் magnetic length ன்னு சொல்றேன்னா இங்க பாத்தீங்கன்னா this north pole இருக்கு இல்லையா, this won't be exactly on this point. இங்க இருக்காது, it's little inside. Okay, so is my south pole. It's not gonna be here, it'll be little inside. Fine. This thing okay, fine. This thing இருக்கு இல்லையா, this thing this in the length, this is the actual length of the magnet we consider called as the magnetic length. Okay, and how much is the magnetic length? Magnitude length, if it was M அதோட 0.84 of its length தான் வந்து my magnetic length. Okay, fine. If L is the actual length, 0.84 of L will be my magnetic length. Fine. So இங்க வந்து if this entire thing was 100 centimeters, if this were 100 centimeters, என்னோட magnetic length will be 84 centimeter. Okay, clear? Okay, on point. இவ்வளோதான். Fine. இப்போ this is my magnetic moment represented by capital M. Well, small m is pole strength. Pole strength is represented by what? Ampere meter. I mean measured in ampere meter, and length is in meter 2. So my magnetic dipole moment. Magnetic dipole moment is measured as ampere meter square. I don't think we'll take breaks in this class. Okay, it will be a full one stretch. I'll finish it off. Let's see. Okay, fine. So இது வரைக்கும் clear. Now next a bar. Okay, now see, this is for ஒரு மேக்னெட்க்கு. ஓகேவா, ஒரு மேக்னெட்க்கு m into 2l is my magnetic moment. And say அதோட ஒரு moment is m ன்னு வச்சுக்கோ, capital M ன்னு வச்சுக்கோ. If I'm having a combination of two magnets, say it's in this way. ஓகேவா, இதோட magnetic moment is m, இதோட magnetic moment is m. Okay, and they are in 90 degrees. ஓகே, இந்த மாதிரி இருக்கும்போது இந்த மாதிரி ஒரு கேஸில் சே the poles, okay, here north, here it's south, here it's south, here it's north. Fine, இந்த மாதிரி இருக்கு. இப்படி இருக்கும்போது we can see the dipole moments, they are perpendicular to each other, இப்படி in this way. Fine. So my magnetic dipole, net magnetic dipole moment will be somewhere here, which can be found using law of vector addition, which is something but p square plus q square plus 2pq cos theta, where cos theta hinga 90 na it's 0, so it's nothing but root over p square plus q square. Paka run. Okay, idukaprom if this is one case, okay, so this will be equal to root 2m in the combination of net magnetic dipole moment. Okay, wow. So let's keep this aside. I'll ask you one more question. Okay, if this entire thing over, okay, let's just duplicate it. Okay, இப்போ இதிலே வந்து if the poles were reversed, okay va, okay, this is north south and இங்க வந்து ஒரு north இங்க south இருக்கு. Here it's north and here it's south. அப்போனா இங்க எப்படி lines போகும், இப்படி வரும். ஓகேவா, so when they tend to represent it pictorially, okay, net dipole moment வந்து இப்படி இருக்கும், not in this direction. இப்படி இது இருக்காது. Okay, this is my net magnetic dipole moment. Okay, or direction. Fine. Okay, so எவ்வளோக்கு எவ்வளோ angle between them குறையுதோ, it's in a function of cos தான். So cos வந்து எப்போ 1 இருக்கும், it will be 1 when the angle between them is 0 degrees. So ரெண்டுமே coincide ஆச்சுன்னா, the angle between two magnetic dipole moments, if it were like this, the angle was 0, then the net magnetic dipole moment will be maximum. Okay, fine. இந்த மாதிரி questions கேட்பாங்க. These are simple questions தான். Okay, இப்போ ஒரு bar magnet இருக்கு, ஒரு bar magnet. It has a magnetic moment of m. இப்போ இந்த bar magnet they have bent it, okay, to form an arc of a circle. Okay, இந்த மாதிரி இருக்கும்போது what will be the, okay, இந்த bar magnet when bent, இதோட மேக்னெட்டிக் மொமெண்ட் எவ்வளோ இருக்கும்? எவ்வளோ இருக்கும்? It depends upon magnetic dipole moment is nothing but pole strength into 2L. Okay, wow. So this is pole strength. So M by 2L is equal to my pole strength. Okay, fine. And இப்போ வந்து இதோட length has changed. Has its length changed? Tell me. The poles, even though they're bent, we can form a line. Okay, now say the angle they made is 60 degrees. Let's go 60 degrees angle. Okay, wow. So 60, 1/6 of the circle. One sixth of a circle is equal to L length, which okay, or 2 pi r into 1/6 is equal to L. Radius is equal to 6L by 2 pi or 3L by pi. So this is my radius. Okay, fine. இப்போ வந்து நான் இந்த லென்த் கண்டுபிடிக்கணும். ஓகேவா? This is a NEET 2013 question. Fine. Okay. இந்த distance தானே நான் கண்டுபிடிக்கணும் to find the moment. This is magnetic length. Fine. Okay. So இப்போ radius கிடைச்சிச்சு. Then this angle will be 30 degrees. Correct? Okay. X by radius is nothing but sin 30 1/2. Fine. Okay. So x by radius, x divided by radius is equal to 1/2, which is equal to x is equal to 3L by 3L pi by 2. This is 2x. So total length 2x is equal to 3L by pi. Okay, fine. 3L by pi தான் வந்து என்னோட மேக்னெட்டிக் லென்த்து. ஓகே, இப்போது அதோட ஸ்ட்ரென்த் எவ்வளோ? இட்ஸ் நத்திங் பட் into m by 2L. Okay, L cancel. Fine. 3m by pi is my new magnetic moment. This question clear எல்லாம் இருக்கும் ப்ரோ. இது எவ்வளோ வெயிட்டேஜ்? திஸ் கொஸ்டின் இந்த சாப்டர் வந்து they ask around 1 or 2 questions அவ்வளோதான். Okay, so 3 இந்த மாதிரி தான் we have to approach questions like this. Okay, fine. Okay, if you have any doubts in this question, just ask me. Understood, bro, Mano. Okay, next, magnetic field lines. Okay. So yeah, only Mano has replied. Okay, fine. Hopefully everyone understood. Okay. Okay, fine. Paka. All right. Next, magnetic field lines. What are magnetic field lines? இப்போ பார்த்தீங்களா, here I represented few lines. These are my magnetic field lines. Basically அவ்வளோதான், அதுக்கு மேலே ஒன்றும் இல்லை. Okay, they are closed loops along okay, basic definition, they are an imaginary lines along which magnetic force is felt. Okay, fine. Here in the line தான் வந்து we will feel magnetic force. Okay, fine. And okay, magnetic force இதை ஃபீல் பண்ணும், இந்த லைனில் தான் ஃபீல் பண்ணும். ஓகே, தேர் ஆர் ஃபியூ ப்ராப்பர்ட்டிஸ் ஃபார் மை மேக்னெட்டிக் ஃபீல்ட்ஸ். ஒன்று, தே ஆர் க்ளோஸ்ட் லூப்ஸ். Okay, they are closed loops as I showed you here. Two is that second property, say a magnetic line is in the gauge. No, they are not like this, but say I was able to produce a magnetic field line. It's like this. Okay, in the field line, okay, in the point or the direction is given by the tangent at that point. In the point the direction is given by tangent at that point. Makes very much sense la. In the point எப்படி போகுது, அந்த பாயிண்ட்ல wherever it was directed, that is given by my tangent. Simple. Fine. Okay, okay, fine. Okay, stronger the magnetic field, closer the lines are. Okay, if somewhere magnetic field is more, apna lines are closer. Okay, weak region la they are far apart. Okay, next fourth one, one more, this last point, two magnetic field lines irukliya, they can't coincide. Okay, fine, I'll tell you why. Say I have a compass. Okay, compass la if I keep it in this magnetic field line na, it will direct along the line. Okay, நான் அப்படியே இந்த காம்பஸ் இந்த ஃபீல்ட் அப்படியே மேலே எடுத்துகிட்டு போகும்போது it will perfectly form this curvature here. Okay, because the direction of field at that point is given by tangent at every point. Okay, fine. இப்போ ரெண்டு இன்டர்செக்ட் ஆகுதுன்னு வச்சுக்கோங்க இந்த பாயிண்ட்ல. Okay, okay, fine. In the point la, if I take tangent, there are two tangents in actually இப்படி ஒரு டைரக்ஷன் இருக்கும். ஓகே, இப்படி ஒரு டைரக்ஷன் இருக்கும் and then இப்படி ஒரு டைரக்ஷன் இருக்கும். ஃபைன், ரெண்டு டைரக்ஷனில் இருக்கும். ரெண்டு டைரக்ஷனில் இருக்கும்போது மை மேக்னெட்டிக் காம்பஸ் ஓட நீடில் it cannot show two directions at the same time. Okay, so it can be said that magnetic fields lines, they do not intersect at all. Okay, pakka. Hopefully this makes sense. Fine. Now field due to dipole. Guys, இப்போ வரைக்கும் we have discussed about how this is. Okay, yeah, field lines பற்றி பேசியிருக்கோம். Dipole or magnetic bar magnetism dipole டிஸ்கஸ் பண்ணியிருக்கோம். இப்போ எலக்ட்ரிசிட்டியில் electric fields and potential I taught you how field at different points of different points around electric dipole can be expressed. Okay va, the exact same thing we'll apply it here. Avladhan, we don't have to derive. Okay, நீங்க அது ஞாபகம் வச்சிருந்தா இது ஞாபகம் வச்சுக்கலாம், இது ஞாபகம் வச்சிருந்தா அது ஞாபகம் வச்சுக்கலாம். Okay, it's simple. Fine. Now okay, fine. நான் ஃபிசிக்ஸ் எப்படியாச்சும் I should get 100 plus possible. Yeah, it's possible. Dakshin, don't stress yourself, okay? It could be a little overwhelming when you realize that you haven't prepared much, okay? You will feel, you won't feel like solving question நீ எக்ஸாம் ஹாலில் போகும்போது. Don't worry, it's okay. uh, Relax yourself and then solve questions. So just solve questions from all the important chapters mattum. You'll easily get 100 plus, don't worry, okay? Fine. Okay, now where was I? Okay, now field due to dipole. Electric dipole, I'll write it on the left. Magnetic dipole, I will write it on the right. Write it on the right, okay? Electric dipole. You எழுத தேவையில்லை, you just know that. Fine. Okay, electric dipole, phi, okay? Field on the axis is given by 2k p by r cube, right? Okay, where r is the distance from the center, okay? இந்த பாயிண்ட்ல field கண்டுபிடிக்க, r is the distance from the center of the dipole. இது வந்து எலக்ட்ரிக் ஃபீல்டால், ஓகே? அதே மேக்னெட்டிக் டைப்போலால் if you see now, my field at that point will be equal to 2 into c. M is my magnetic dipole moment by r cube. What is c? K is my Coulomb's constant. C is my, not K. K is equal to 1 by 4 pi epsilon naught. Okay. Right. This is nothing but C is equal to nu naught by 4 pi. Okay. This is my C. This is on the axis. Fine. Next is my equatorial line. Equatorial line electric dipole, we know the formula. See, electric dipole, equatorial, it's a beautiful derivation. This will be the net, correct? This is the net in electric field. Okay, fine. Inga the field is nothing equal to well, this is R. Okay, அதே magnetic field magnetic dipole எப்படி இருக்கா? உள்ள வந்து it goes from south to north, மேலே வந்து it goes from north to south. Fine. Okay, so if we consider this as our magnetic moment, okay, direction இப்படி இருக்கு, okay, dipole moment. But அதே அங்க வந்து the field line goes in the opposite direction on the point. So here also, similar to this one, it will be negative தான், correct? It will be நெகட்டிவ் தான். ஃபீல்டு இப்படி இருக்கும். Here it will be minus C P bar I R square, where this is my R, equatorial line, axial line, and this is at any plane. I mean, okay, fine. வேற என்ன இருக்கும்? அவ்வளோதான், ஃபைன். ஓகே, இங்கே பார்த்தீங்கன்னா why is it negative? Just let me know. பாசிட்டிவ்லேருந்து we know that the field lines arbitrarily it's taken from positive to negative or negative to positive. Tell me in the comments. Fine. இங்கே பார்த்தீங்கன்னா if it depends upon if it were a positive charge or negative charge. If this was a positive charge, okay, positive charge will repel, negative charge will attract. Okay, appo it's in this direction, and this is my field line here. Okay, if it were a negative charge, appadi opposite side it will be in positive. Fine. Okay, this is for my, I know how, I hope this you understood why this happens here. Ulla vande dipole moment is in one direction, but it's in the other direction. Okay, the field line on the point where I'm supposed to find it. Okay, fine. Now same electric dipole we saw it experiences torque in an electric field. Okay, fine. What is torque? Torque is nothing but force into perpendicular distance from the axis of rotation, F cross R or R cross S. Fine. Okay, now here torque is nothing but basically my dipole moment into field. Okay, dipole moment has charge, field தனியா இருக்கு, field into charge is my force, dipole moment has the distance between these two. So isn't that torque already? Fine. Yeah, so tau bar is equal to P bar cross E bar. Fine. This is my torque on a electric dipole. Okay, fine. If it now here it's in magnetic dipole, in magnetic we can say, take the same torque tau is equal to B bar cross M bar. Okay, this is torque on a magnetic dipole. Easy. Hope this is clear. This is all based on analogies. We are able to, we are finding it out. I'm not using any derivation here. Okay, fine. Okay, now let's shrink this one down to okay, we have shrunk it down. So இப்போ ஒரு magnetic field இருக்கு இப்படி. ஒரு magnetic field இருக்கு. This magnetic field I am having my magnet here. Nice magnet. இப்படி இருக்கு. Okay, from south to north there is my field I mean magnetic lines of force உள்ள வந்து இப்படி தான் போகும். ஓகேவா? angle made is theta. okay fine. இப்போ to find torque acting on it, it's nothing but m cross b or b cross m. fine. magnitude மட்டும் direction கண்டுபிடி, it's little tricky. fine. m cross b magnetic moment into field. அப்போனா we'll take it an arbitrary manner. ஏன்னா இங்கேயும் வந்து it's dipole moment into field, so it's magnetic moment into field தான். ஓகே, இந்த மாதிரி இருக்கும்போது இதோட magnetic moment is nothing but m. okay, the field is b. okay, the angle it makes is with the field is theta. So can I write my torque is equal to mb sin theta? right? Makes sense, la? okay, so this thing can also be rewritten as mb sin theta. okay, fine. Now potential energy. fine. This is also a little, it's easy now. fine. Potential energy is equal to p bar dot e bar or pe cos theta. it's in minus pe cos theta. okay, minus p bar dot e bar, or it can be written as p bar dot pe cos theta. இப்படி ஒரு represent பண்ணலாம். this is for my electricity. fine. okay, இதை வந்து நான் இப்போ மேக்னட்டிசம்க்கு எழுதணும்னா என்ன எழுதுவேன்? p பார்க்கு பதிலாக I'll write it's minus m dot c, m dot b. okay, or mb cos theta. fine. okay, clear. fine. இப்போ வந்து say my due to the external torque. okay வா? payment is not showing payment history. okay, the stream quality is a little poor now. நான் தமிழினி I'll look into it that. okay, நீங்கள் ஆப்பில் போனீங்கன்னா there's a G forms open. okay, yeah, Safura, the video is lagging. okay, for some reason. if you go to the app, okay, ஆப்பில் என்ன பிரச்சனை இருந்தாலும் there was a G forms open. இப்போ இது இல்லை. okay, இந்த சப்ஸ்கிரிப்ஷன் நீங்கள் போய் மை ப்ரொஃபைல் போய் சப்ஸ்கிரிப்ஷனில் பார்த்தீங்கன்னா you would have current plan என்னது, பேமெண்ட் ஹிஸ்ட்ரி என்னது, அதெல்லாம் இருக்கும். if it's not there, contact the support team. அதுலேயே வாட்ஸ்அப்பில். okay, fine. வீடியோ லாக் ஆகுது. எஸ், வீடியோ லாக் ஆகுது. ஐ டோன்ட் நோ வை. How bad is it? இப்போ ஓகேயா? When the video gets better, just let me know. Yeah, இப்போ I think it's okay. இப்போ I think it's okay. Yeah. இப்போ ஓகே. யா இப்போ நல்லா இருக்கு. நோ வாய்ஸ் பிரேக் ஆதா? Okay, it's better now. Fine. It's pakka now. Okay. Where do we stop? இந்த மாதிரி ஆச்சுன்னா ப்ரோ கிளாஸோட ஃப்ளோவே ரொம்ப டிஸ்டர்ப் ஆகுது. ஓகே, I was talking about something potential energy. இதுக்கப்புறம் என்ன? Potential energy due to some external torque. ஓகேவா? டார்க்கால there is some work done. ஓகேவா? இந்த கேஸில் there is some torque. Okay, torque there is change in angle. Change in angle அப்போ there is initially some potential energy, then finally there is some potential energy. Fine. So the work done by external torque is equal to my change in potential energy equal to work done by external torque. Okay, fine, paka. It's nothing but m b into cos theta 2 minus cos theta 1 எப்படி தான் வரும்? ஓகேவா? Fine. Potential energy base. Now equilibrium. Stable equilibrium and unstable equilibrium. Equilibrium is when my dipole magnetic dipole has no external torque acting on it. Okay, when you now torque is a function of sine. Okay, sine எப்போ 0 இருக்கும்? when the angles are 0, when the angles are 180. Okay, sine chumma, if you don't know the value how it changes, chumma draw a wave in this form. Okay, everything is 90 degrees. Okay, now this is sine 0, this is 90, this is 180, this is 270, this is 360 degrees. Fine. Okay, so 90 degrees is maximum. Okay, 90 degrees sine 90 degrees is maximum, so maximum torque அப்போ தான் கிடைக்கும். Zero torque is at when it's at 0, when it's at 180 degrees, when it's at 360 degrees. இந்த angle இருக்கும்போது when my dipole moment makes this angle 360 is basically 0 again. So இந்த மாதிரிலாம் இருக்கும்போது this is my field. Okay, dipole moment வந்து I am representing it with yellow. Okay. Fine. Okay. இப்படி ஃபீல்டில் இருக்குது. ஸோ இட் கேன் பி parallel or it can be anti-parallel. பட் அப்போல்லாம் வந்து it will have no no torque. No torque. இந்த பாயிண்ட்ஸ்லாம் வந்து it will have no torque. Fine. No, it will have no torque. Okay. But in the equilibrium appo, one state of equilibrium is called as stable equilibrium, and another state of equilibrium is called as unstable equilibrium. I'll tell you why. If you take chemistry, okay, chemistry la every single reaction, whatever it is, they tend to get into a stable state. நீங்க thermodynamics படிச்சிருப்பீங்க, or say you would have studied it in your what chapter? Nuclei. Okay, adaliyum fission, fusion, everything is done because of stability. Okay, stability means less energy. Lesser the energy, more stable an atom is, more stable anything is. Okay, so இப்போ என்னோட potential energy of my magnetic dipole, if it was least at one case and if it was higher in other case, least இருக்கிறத I would call it stable equilibrium. அதிகமாக இருக்கிறத I would call it unstable equilibrium. Okay, fine. I'll draw these are field lines. Okay, these are my field lines. Magnetic field lines இப்படி இருக்கு. ஓகேவா? Now I'm having my bar magnet here. இதில் வந்து it's north here and it's south here. Okay, and then இன்னொன்று it's south here and it's north here. ஓகேவா? என்னோட மேக்னெட்டிக் ஃபீல்ட் லைன்ஸோட டைரக்ஷன் வந்து இப்படி இருக்கு. ஓகே, ஜஸ்ட் அண்டர்ஸ்டாண்ட், இட்ஸ் கோயிங் இன் திஸ் இட்ஸ் இன் திஸ் டைரக்ஷன். ஓகே, ஹியர் வந்து உள்ள இன்சைட் மை மேக்னெட் எப்படி என்ன டைரக்ஷனில் இருக்கும்? லெட்ஸ் டேக் க்ரீன். சவுத் டு நார்த்தா? ஃபைன். இங்கே வந்து சவுத் டு நார்த் அகேன். திஸ் இஸ் அலாங் த ஃபீல்ட். ஓகே, அலாங் த ஃபீல்ட் எப்படி இருக்கும்? திஸ் இஸ் against the field. Okay, fine. In the case, what will be my potential energy? And what will be the potential energy in this case? Potential energy in this case, it is nothing but mb minus mb cos theta. Cos of 180 is minus 1, making it plus mb. Okay, cos 180 degrees. ஏன்னா this is in this direction and my field lines are in this direction. Okay, இப்படி இந்த direction இருக்கு. Okay, so cos 180 it's minus 1, so my potential energy in this point is plus mb. அதே இந்த கேஸில் cos 0 is 1, so it's minus mb cos 0. So cos 0 is 1, so my potential at this point is minus mb தான். Okay, fine. Okay, ரெண்டுமே ஈக்குலிபிரியம் ஸ்டேட் தான். ஆனால் ஒரு கேஸில் இட் ஹேஸ் ஹையே ப்ளஸ் எம்பி, இன்னொரு கேஸில் இட் ஹேஸ் மைனஸ் எம்பிஎஸ் பொட்டன்ஷியல் எனர்ஜி. ஸோ மைனஸ் எம்பி it is taken as my stable equilibrium. It has less potential energy, like stable equilibrium. This is my unstable equilibrium. கன்ஃபியூஸ் பண்ணிக்காதீங்க. இஸ் வெரி சிம்பிள் கான்செப்ட். ஓகே ஃபைன். ஓகே fine. Time period, a beautiful concept. Time period, Gauss law and magnetism. Earth's magnetism, angle of dip, angle of declination, true dip, galvanometer, behavior of substances, magnetism, magnetic susceptibility, properties of substances. Yeah, we have a, a, a lot of concepts to cover. Okay, now time period. இதுக்கு முன்னாடி we'll solve one question. Okay fine, we'll solve one question மட்டும். We'll solve one question. Okay, a bar magnet of magnetic moment 2 into 10 to the power minus 4, I mean plus 4, is free to rotate in the horizontal plane. Okay, horizontal magnetic field is 6 into 10 to the power of minus 4 Tesla. Joule per Tesla, this is in Tesla. Okay fine. Work done and make it's in such a way. Okay wow, this is my field, this is my magnetic moment. Okay wow, how much work will be done if I want to move this magnet from 0 degrees to 60 degrees? How much work will be done? Is nothing but change in potential energy. From 0 degrees, we know the potential energy is minus mb. Okay wow. At 60 degrees, the potential is nothing but mb minus mb into cos 60 is root 3 by 2. Cos 60 is 1 by 2. So it will be minus mb by 2. So my change in potential work done is nothing but mb by 2 joules. Okay wow. What is mb? Multiply pannuma, it's nothing but 12 divided by 2, so 6 joules of work. Okay pakka 6 joule of work. Nothing more, nothing less. Okay fine. Time period. There's one more question too. I think I want to solve it, but it's okay fine, we'll solve it. Pona class I was not able to solve questions. Okay fine. இப்போ வந்து it's in 0 degrees. Okay wow. This is my magnetic moment, this is my field. Okay, they are in 0 degrees. Okay fine. Ipo now this is made to have an angle of 60 degrees with the field. Okay wow. இதுக்கு வந்து கொஞ்சம் டார்க் அவசியமா இருக்கு. டார்க் இதுக்கு வந்து கொஞ்சம் ஒர்க் அவசியமாக இருந்திருக்கு. ஒர்க். This work is nothing but W from 0 degree to 60 degrees. Okay wow. Fine. So my MB is equal to W. In the question we found out that from 0 degrees to 60 degrees amount of work required is nothing but MB by 2. Fine. Okay, so my MB by 2 is equal to W. Fine. இப்போ torque required, torque 60 degrees இருக்கும்போது what will be the torque acting on it? 60 sin 60 so MB sin 60, M B sin 60 is root 3 by 2. Okay, M B sin 60 degrees will be my torque acting. Paka done. Okay, so MB root 3 by 2. MB root 3 by 2 la MB by 2 எடுத்துடலாம். MB by 2 is equal to my W. So root 3 W is the amount of torque required to hold my magnetic dipole at 60 degrees with the field. I hope this is clear. Okay. Okay. Fine. I will go to time period. Fine. Okay. Fine. Electric dipole, we know time period is nothing but 2 pi root over I by T. Fine. I is nothing but moment of inertia. I. P is nothing but dipole moment, and E is nothing but my field, electric field. Okay. Fine. அதே வந்து magnetic field, how will I write it? Same, exact same. Time period T is equal to 2 pi root over I by this is my moment of inertia divided by ME, mean MB. Okay, wow. They'll ask so many questions from this concept alone. Time period change when I increase my இப்போ பாருங்களேன், the first question which I solved today was bending the second question which I solved today, bending a bar magnet to an arc. Okay va, fine. இப்போ when I have a bar magnet, it will have a specific moment of inertia. அதே வந்து ஒரு ஆர்க்கா மாத்திட்டேன்னா it will have a different moment of inertia. For a different moment of inertia, the I value changes. Fine. So time period la மேல இருக்கிற I changes. And also for a different moment of inertia, for a different length of for a different structure, the magnetic dipole moment also changes. And that change we have to consider it in the denominator as well. So மேலக்கும் change ஆகும். So 2 pi root over I la I changes because of the structural change, and also my M changes because of the structural change. Fine. And also depending upon the axis, I can vary. Maybe central இருந்து பண்ணி தள்ளி வச்சிருந்தாங்கன்னா, so you must know foundations, basics of what mechanical what your system of particles of rotational motion, அதோட ஒரு பேசிக் ஐடியா உங்களுக்கு இருக்கணும். then only you will be able to solve questions like this. Okay, time period change வச்சு நிறைய கேட்பாங்க. So yeah, சொல்லியாச்சு. Okay. Yeah, root 3W. Gauss law and magnetism. Okay. Gauss law basically என்ன சொல்லுது? It basically, அது வந்து electric lines of field force. Okay va, electric field or flux வச்சு சொல்லுவாங்க. Flux concept is nothing but number of lines of force. It depends upon charge q by epsilon naught. Okay, or field into area. Okay, for a 3-dimensional structure, amount of number of field lines going outside is what its fluxes. Okay, fine. இப்போ if you take a magnet, okay va, இப்போ I'll write for electricity. Phi in electricity is nothing but q by epsilon naught. Okay va, because if I had a charge na, if it was positive charge na, it only have field in one direction. Okay, It'll only go out. Okay, we don't have any lines coming inside or forming a closed loop. Okay, அதே வந்து for magnetism it is equal to 0 for a 3-dimensional structure, because ஒரு பார் மேக்னெட் எடுத்து உள்ள வச்சிங்கன்னு வச்சுக்கோங்களேன், inside any structure, ஒரு Gaussian surface எடுத்து, inside that you can't actually have net line field outside. வெளியே எவ்வளோ ஃபீல்ட் ஆஃப் எவ்வளோ லைன்ஸ் ஆஃப் ஃபோர்ஸ் போதோ அவ்வளோக்கு அவ்வளோ உள்ளேயும் வரும். ஸோ இட்ஸ் பிகாஸ் தேர் ஆர் க்ளோஸ் லூப். ஸோ வாட் எவர் கோஸ் அவுட் கம்ஸ் பேக் இன். ஸோ அந்த மாதிரி இருக்கும்போது த நெட் ஸோ பிகாஸ் ஃபீல்ட் மேக்னெட்டிக் lines are closed loops. Okay, fine, they're closed loops basically. Okay, done. I hope it's clear. There you go. So it has no flux at all. Okay, so my what flux is nothing but field into area integral EDA. இதுக்கு வந்து it has something. அதே வந்து integral BDA, it's always 0 because magnetic fields of line they are closed loops, so whatever goes out comes in again. Okay, Earth's magnetism okay, angle of declination, dip இருக்கு, galvanometer இருக்கு, behavior substances இருக்கு. Okay, fine. Earth's magnetism, it's simple now. See, when you point when you take a magnet, okay, no, okay, compass, yeah, a compass எடுத்து வைக்கும்போது நார்த் போல் வந்து நார்த்து காட்டும், சவுத் போல் சவுத்து பாயிண்ட் பண்ணும், கரெக்டாக? ஓகே, இந்த நார்த் pole of the magnetic needle points to the north direction. South pole points to the southern direction. Okay, fine. But we know north attracts south, south attracts north. So since my north pole of my magnet points to the north pole of the earth, can I say that my geographic north pole of our planet is magnetic south pole, right? Makes sense la? So south pole then வந்து என்னோட magnetic north pole will get attracted towards the direction. Illa it won't, right? Yeah, so this is what it is. the geographic south and my magnetic south is my geographic north. Okay, pakka, fine. Okay. When they completed 10th and 11th, Sandeep, please don't spam your text. I'll definitely read it. Okay. We have a yearly course, a normal slow syllabus cover பண்ணுற ஒரு கோர்ஸ் இருக்கும். அதுக்கப்புறம் we have a crash course. Everything is free, available on YouTube. Stress series மட்டும் is available on our app. இப்போதைக்கு it's available for NEET 2026. Okay, if you want, go check it out. Well, you're in 11th, you're in 10th grade. I mean, you're entering 11th grade. So I don't think it's necessary, Sandeep. Don't stress yourself out, okay? We have YouTube videos. If you want to study, do check it out, okay? Avladhaan. Fine. This is what Earth magnetism is. Fine. Okay. Angle of dip. A magnetic needle irukku. Okay va. And the magnetic needle, it is made to rotate free in vertical plane. Okay va. Fine. So vertical plane na இப்படி இந்த plane it's free to move. Okay. இந்த மாதிரி நான் ஒரு நீட் வச்சிருக்கும் போது it will still point இப்படியா. Fine, because see, when I keep it like this, my north pole will point towards north, my south pole will point towards south. Okay, when I keep it in this way, it will still point in this manner da, right? Okay, now the needle can make angles with the horizontal actually, because earth எடுத்துக்கோங்களேன். This is a very beautiful concept. Okay, earth எடுத்துக்கிட்டிங்கன்னா, this is how the lines of forces are. பக்காவா? Okay, something like this. Okay, இப்போ இங்கே பார்த்தீங்கன்னா, if I place my இப்படி இருக்கிற காம்பஸை if I keep it like this na, it will stay flat here. Okay, அதே வந்து if I go towards here na, it will adjust with the curvature. Okay, it will adjust with the curvature. Line இப்படி போகுது. Okay, so இந்த பாயிண்டில் இருக்கும்போது it will be like this. ஒரு பாயிண்டில் it will have zero angle with the horizontal. அதுக்கப்புறம் it will form like this. Okay, this is the angle it makes with the horizontal. Okay, that's called as my angle of dip basically. Simple, very simple concept. நிறைய பேர் போட்டு குழப்பிட்டு இருப்பாங்க. Yeah, it's a very simple concept. So this is my angle of dip basically. Fine, so you have a needle, அதை வந்து vertical planeல வச்சு அதை ஃப்ரீயாக மூவ் பண்ண வைக்கும் போது it will align with the magnetic lines of force of earth. அப்போ it makes angle with the horizontal, and that angle is called as my angle of dip. It is represented with this symbol. Okay, fine, all right. Okay, conventionally this dip angle இருக்கு இல்லையா, it's taken, this is my geographic north, this is my geographic south. Conventionally these angles are taken as positive, here the angles are taken as negative. Okay, still the angles are angles தான், but எங்க angle நடக்குது, எங்கே it's available அதை பொறுத்து. If it were above the equator towards the north pole na, the dip is taken as positive. அதே if it were near the southern pole na, the dip is taken as negative. Okay, fine. Okay, இது வந்து இப்படி இருக்கு. ஓகேவா, if I were in north pole na எப்படி இருக்கும், north pole field lines இப்படி போகுமா, கரெக்டாக இப்படி போகும். ஸோ அதை வர்டிக்கலாக நான் இப்படி வைக்கும்போது it will be free, and then it will be பக்கா perpendicular. Okay, makes sense. அதே சவுத் போல் போனால் it will be again perpendicular, because அங்கே வந்து என்னோட ஃபீல்ட் லைன்ஸ் வந்து இப்படி வரும். ஓகேவா. ஸோ when I freely keep my magnetic needle, it will align with this and it will stay perpendicular to the horizontal surface. So here the angle of dip will be 90 degrees. Very simple, beautiful concept, இல்லையா? Right? Okay. Fine. So this is my horizontal. This is my horizontal plane. என்னோட earth's magnetic field இப்படி போகுது ஓகேவா fine. This angle is my angle of dip. This is my earth's magnetic field. இது வந்து horizontal plane. This is my vertical plane. Okay fine பக்கா. This horizontal planeல the component of magnetic field எவ்வளோ இருக்கும்? Horizontal planeல magnetic field will be equal to B earth into இதோட cos component cos of angle of dip. Okay, this is my magnetic field in horizontal horizontal component. அதோட vertical component is nothing but vertical plane magnetic field is equal to BE sin fine அவ்வளோதான். ஓகே ஓகே இப்போ வெர்டிக்கலோட மேக்னெட்டிக் ஃபீல்டு வெர்டிக்கல் பிளேனில் மேக்னெட்டிக் ஃபீல்டு டிவைட் பை ஹாரிசான்டல் பிளேனில் மேக்னெட்டிக் ஃபீல்டு இஸ் ஈக்குவல் டு வாட்? சைன் பை காஸ் இஸ் ஈக்குவல் டு tan ஆஃப் மேக்னெட்டிக் ஆங்கிள் ஆஃப் டிப். ஓகே எவ்வளோதான். இதுக்கப்புறம் ஆங்கிள் ஆஃப் டெக்ளினேஷன் fine. Fine. Okay. Angle of declination is a little it needs a little amount of thought into it. Okay va fine. இப்போ என்னோட நார்த் போல் இப்படி இருக்குது, this is my south pole. Geographic. ஓகேவா அது வந்து அது வந்து ஒரு பிளேனில் இருக்குது. ஓகேவா தட் என்டையர் திங் இட்ஸ் இன் அ பிளேன். ஓகே திஸ் இஸ் மை geographic north south இருக்கிற plane fine. Okay, but if you take my magnetic field magnetic plane, this is my geographic north pole south pole, அதில் ஒரு plane போட்டால் that will be my geographic meridian. Okay, and then you ஆனால் அந்த எக்ஸாக்டாக அதே லொக்கேஷனில் மை நார்த் போல் ஆஃப் மை மேக்னெட் அண்ட் மை சவுத் போல் ஆஃப் மை மேக்னெட் ஒன்ட் பி ஆஃப் மை எர்த்தோட மேக்னெட்டிக் ஃபீல்டு. இஃப் யூ கன்சிடர் தேல் பி சம்வேர் கொஞ்சம் மாற்றி இருக்கும். ஓகேவா இப்படி இருக்குன்னு வச்சுக்கோங்க. ஓகேவா தேர் இன் சம் ரேண்டம் வே திஸ் வில் பி மை மேக்னெட்டிக் மெரிடியன். ஸோ பேசிக்லி a plane which passes through the geographic centers அது ஒன்று இருக்கு. and then a plane which is used to pass through in this direction in the magnetic direction, so magnetic meridian. So magnetic meridian, geographical meridian. Okay, ரெண்டு different plane இருக்கு. ஓகேவா fine. I'll represent it in a very understandable manner கொஞ்சம். ஓகே இதை தூக்கி தள்ளி வச்சுக்கலாம். ஓகே திஸ் வில் பி மை this will be my okay. So there are two planes which do not coincide. These two planes, they do not coincide. Say this is my geographical meridian plane and this is my magnetic meridian plane. Okay va இதுக்கு ரெண்டுக்கு நல்ல ஒரு ஆங்கிள் இருக்கா? This angle is called as my angle of declination. Okay, this is my horizontal, this is my vertical, and இப்படி வரும் என்னோட magnetic இது earth's magnetic field. Summary video. 3 Earth's magnetic field. Okay, fine. This plane is my, okay, there are two planes. I think I represent it in the best way possible. Okay, this is my angle of declination. This is my angle of dip. This is my angle of declination. Okay, va. Idhari clear ah? Hmm. Okay. Why is it necessary? Why is this angle of declination important? Yes, bro. Okay. Why is this angle of declination important? When this angle of declination is what shows me the exact north. Okay, geographical north ஒரு இடத்துல இருக்கும், magnetic north கொஞ்சம் தள்ளி இருக்கும். ஓகேவா? ரெண்டுக்கும் நடுவில் there is an angle difference. That angle difference is my angle of declination. Okay, if you take a compass, it will direct in this direction. இப்படி காட்டும், இங்கே காட்டும், நார்த்து இப்படி இருக்குன்னு காட்டும். பட் மை நார்த் இஸ் ஆக்சுவலி ஹியர். ஓகே, தேர் இஸ் an angle difference அப்போ. கரெக்டாக? that angle difference is my angle of declination. Fine. Why is this showing here? Because earth's magnetic field இப்படி இருக்கு, அதோட horizontal component எடுத்தோம்னா, which is nothing but b e cos delta, it will be here. Fine. I hope this is clear. Angle of declination. Fine. Okay, we'll take a 5-minute break, and then true dip, apparent dip. Okay, அதெல்லாம் படிச்சு I will clear it out, sort it out. Okay, class starts at 9 o'clock. Okay, say 9 o'clock. அதுக்கப்புறம் ஒரு 20 minutes we'll finish it off. Class resumes. Okay, have something. Okay, or 5 minutes. I'll see you in 5 minutes. Okay, fine. Hello, hello, hello everyone. Hi. Okay. It was supposed to be 9 o'clock. Now I'm on time. Hi. Fine. Very, very simple concept தான் இதுக்கப்புறம் we'll finish it off. Fine. Okay. But where did I stop? Angular declination. Okay. There is a concept of true dip and apparent dip. Okay. That's also very simple now. Okay. True dip is when I'm hi. Hello everyone. Okay. The video is lagging again. I don't even know what the issue is. Oh, okay. Now it's Paka. Yes. Okay. Fine. Where did I stop? Where did I stop? Apparent dip, apparent dip, and actual dip. Okay. True dip and apparent dip. Fine. Okay. True. What is true dip? What is apparent dip? We'll see. Hmm, fine. If the see we know we have a magnetic meridian or plane, correct? If this plane doesn't have anything, okay. If the needle wasn't in this plane, if it was in some other plane, okay, wow. Okay. If the needle, needle was supposed to be in this plane, magnetic meridian plane, but it's in some random plane. அப்போ அந்த பிளேன்ல இருக்கும்போது still there will be some dip. That angle is called as my apparent dip. Okay, this is how my north south is shown. This is apparent dip. In the angle is called as, take it as alpha. Say the plane ko நடுவில் இருக்கிற angle. பக்கா fine. Very okay. Now it's fine. Now it's fine. Now it's fine. Okay. Fine. Okay. So now what is tan of apparent dip? The apparent, you know, basically apparent na it is in a different plane, not in a magnetic meridian. Magnetic meridian is a plane. And the plane பதிலா பக்கத்து பிளேன்ல வேற எங்கேயோ இருக்கு. Okay. ஆனா அங்கேயும் it's showing dip. That is an apparent dip. Okay. True dip is when it's in magnetic meridian. Fine. Okay. So this is equal to V by H இருக்கும். But it's nothing. ஏன்னா இங்க வந்து this is H. V is constant தான். V இங்க constant. ஓகேவா? Don't worry. V is constant. H வந்து here it's H is B cos theta, cos delta, and taking H as separately, it's nothing but H cos alpha. H cos alpha. Okay, H has, this is horizontal magnetic field. Okay, in the horizontal magnetic field order cos component தான் வந்து it's involved in this one. Okay, true is nothing but tan of delta is equal to H by V by H. Okay, fine. True dip, apparent dip. This is my apparent dip. This is my true dip. Very simple concept. They won't ask persa question. I'll include this in the test series. Okay, I mean in the question solving thing. Fine. Okay. Is if they say the dip apparent dip is equal to 45 degrees. Okay, wow. And alpha is equal to 30 degrees. Okay. அப்போனா என்ன V by H cos alpha is equal to 1. V is equal to H cos alpha. Cos alpha is nothing but, what is cos alpha? Cos 30. Cos 30 is nothing but root 3 by 2. H root 3 by 2. V by H is equal to root 3 by 2. Root 3 by 2 is my true dip. கரெக்டா? இப்படி கண்டுபிடிக்கலாம். This is one of your previous year questions தான் நினைக்கிறேன். இந்த மாதிரி தான் கேட்டிருந்தாங்க. I remember it being asked in such a way. Okay. A galvanometer is something, a device which is used to determine the direction of current. Okay வா? Basically இது எப்படி இருக்கும்னா, you'll have circuitல you'll have galvanometer connected. Okay. அந்த circuit wireலாம் போய் ஒரு circular loopல connect and then it will go back again. Okay, when current goes through a circular loop, okay, say if it's in this direction and it comes out இப்படி, so in this direction the field is inwards. correct? Magnetic field is produced, and the magnetic field produced ஆகிறதுல a magnetic needle is kept here. Okay, this needle will show deflection. correct? Okay, so you have a magnetic field and then you have a horizontal Earth's horizontal magnetic field. Okay, because it's in horizontal plane. Okay, இது ரெண்டுக்கு நடுவுல it will show some deflection. The more this magnetic field becomes, more deflection it will show, this angle will increase. Okay, that's basically what a galvanometer does. Okay, taking this as theta. Yeah. Okay. Tan of this theta, theta is nothing but, see, இப்படி என்னோட in the direction is my magnetic field. Okay, Earth's magnetic field is in this direction. It shows a deviation somewhere here. Okay, this is my Earth's magnetic field. This is the produced magnetic field due to the current. And ரெண்டுக்கு நடுவுல it shows some deviation. correct? It shows some deviation. Fine. That it makes an angle with the Earth's horizontal magnetic field. And the angle which I am able to find my tan theta, which is equal to magnetic field produced by the wire divided by Earth's horizontal magnetic field. அவ்வளோதான், பக்காவா முடிஞ்சு. This is what they ask in this. So B is nothing but, B is equal to mu naught I n by 2r because of a circular loop. Okay, அவ்வளோதான். Fine. I can write from this equation that my B is equal to H tan theta, right? And my, okay, and my H B badala I can write it as mu naught I into n by 2r is equal to my H tan theta. correct? I current is equal to H into 2r divided by mu naught n into tan theta. So my current value is this. Okay, wow. This is nothing but my constant. Taking this as constant, I have figured out a relationship between current and theta. So if my current increases, my angle also increases. Apona it will get more deflected towards the produced magnetic field more if this kept increasing, if current kept increasing. Okay, fine, pakka. All right, now behavior of substances. Fine, we let's figure out why the substances have magnetic field. I mean they have magnetic properties in the first place. Okay, electrons இருக்கு இல்லையா, electrons revolve. When they revolve around the magnet, okay, when they revolve, they form tiny, they are like a tiny circuit mari. Okay, and it's in a loop. So loop when the tiny, I mean when electric field, I mean electricity current pass through a loop, closed loop, it forms magnetic field. Okay, that's what causes magnetic properties. Okay, if you have uh, unpaired electrons, you'll have more of this property compared to that of paired electrons. Fine. Okay, a current loop க்கு வந்து magnetic field இருக்கும் இல்லையா, that's what we studied. கரெக்டா? Okay, அதனால this is why substances show this magnetic property in the first place. Fine. We have diamagnetism, ferromagnetism, paramagnetism. Ferromagnetism is simple, we know everything. Diamagnetism and paramagnetism oda konja theory portion I will cover it in the this class, question solving class. Adha வந்து diamagnetism, ferromagnetism, paramagnetism oda it has to be tabularized in proper way. Okay, so I'll discuss in that class. But basically diamagnetism என்னன்னா, நீங்க molecular orbital theoryல பார்த்திருப்பீங்க. If it had two, I mean electrons in one orbit in the end, it exhibits diamagnetism. அதாவது ஒன்று ஒரு டைரக்ஷனில் சுற்றும், other one will be in opposite direction. ரெண்டுமே opposite magnetic field produce பண்ணி it will get cancelled out. Fine, that's what diamagnetism is all about. Okay, paramagnetic substances ஒரு எலக்ட்ரான் அன்பேர்டாக இருக்கும். ஸோ ஒரு அன்பேர்ட் எலக்ட்ரான் விச் இஸ் ரெப்ரசன்டட் பை இந்த மாதிரி இருக்கும் மாலிகுலர் ஆர்பிட்டல் தியரியில். ஓகே, அதே வந்து டயாமேக்னட்டிசமில் இப்படி இருக்கும், ஆப்போசிட் ஸ்பின். ஸோ ஒரு டைரக்ஷன் ஸ்பின் பண்ணால் இன்னொரு டைரக்ஷன் ஸ்பின் பண்ணும். ஸோ நெட்டாக தே ஓன்ட் பி நோ மேக்னெட்டிக் மூமெண்ட். ஓகே, ஹியர் யூ வில் ஹேவ் மேக்னெட்டிக் மூமெண்ட். Fine, this is my paramagnetism, this is my diamagnetism. Ferromagnetism we'll discuss later. Okay, so this is what it is. Because of presence of this unpaired electron, there are magnetic properties to substances. Okay, fine. Let's see magnetic intensity, magnetizing field, and magnetic susceptibility. இதுக்கு முன்னாடி வந்து magnetic intensity முன்னாடி there is something called as magnetization. Okay, magnetization இப்போ பார்த்தீங்கன்னா I'm having a magnet. Okay, I'm having an ferromagnetic substance. அதை வந்து I'm magnetizing it. It becomes a dipole. It becomes a bar magnet. Okay, this bar magnet has some dipole moment. This moment over the entire volume of the ion block is what my magnetization. அதாவது how much magnetic moment it tends to develop per unit volume. Okay, per unit volume, magnetic moment per unit volume. Okay, this is my magnetization. Fine. Okay, it is represented by I bar because magnetic moment is a vector. So yeah. கிளியரா இது வரைக்கும்? Okay, fine. Next, magnetic intensity. Fine. Okay, பார்க்குறேன். Magnetic intensity or magnetizing field. ஒரு solenoid இருக்கு. ஓகேவா? அதில் வந்து I'm having a ferromagnetic substance inside. ஓகே, உள்ளே இருக்குது. solenoidல current induce பண்ணுறேன். This will produce magnetic field. This magnetic field will induce magnetic moment inside this conductor. Okay, fine. That's what basic concept. இப்போ இந்த solenoidக்குள்ளே இருக்கிற magnetic field, it depends upon ஒன்று externala how much I'm applying. That is my magnetic field intensity or H. And also internala how much it's able to develop within itself. Okay, that is my magnetization. Depend by I. Okay, so H is nothing but வெளியே இருந்து நான் தரேன். ஓகே, வெளியே இருந்து நான் எவ்வளோ கொடுக்குறேனோ magnetic intensity or magnetizing field எவ்வளோ தரேனோ that is my H. Magnetizing field is nothing but external because of the wire in loop, it produces a magnetic field. That magnetic field is my H, magnetizing field. It magnetizes stuff. Okay, இப்போ அந்த solenoidக்குள்ளார இப்போ நான் magnetic field பார்த்தேன்னா it depends upon the current. Okay, currentaல produce ஆகிற magnetic field which induces magnetic field inside the conductor. Okay, inside the core conductor. Okay, அது ஒன்று. And then 2, how much this core conductor is able to increase itself, how much it's able to get magnetized. சும்மா if it were vacuum na ஒன்றுமே இருக்காது, the magnetic field will be equal to how much the solenoid is trying to induce. ஓகேவா? ஆனால் உள்ளே ஏதோ இருக்குது, உள்ள அந்த மெட்டீரியல் எவ்வளோ அதை இன்க்ரீஸ் பண்ணுது அதை பொறுத்து my magnetic field inside the solenoid will change. ஓகேவா? So my magnetic field inside the solenoid depends upon how much the solenoid actually has. Okay, how much it exerts, how much it tries to magnetize the iron, plus how much the iron is able to get magnetized. Okay, fine. This is what it is. It depends upon these two factors. Okay, இது கொஞ்சம் பெருசாக எழுதணும்னா my B is equal to mu naught into H plus I. mu naught is my proportionality constant, H is my magnetizing field, I is my magnetization, how much I'm getting magnetized. Okay, it's like ஒரு field போகுது. ஓகேவா? ஒரு 10 Tesla of field is there. Okay, already that is trying to magnetize me, and then I got magnetized so that I am myself, I am able to produce 2 Teslas of magnetic field, 2T magnetic field. Okay, so என்னோட magnetic field and that magnetic field together becomes the entire magnetic field inside the solenoid. I hope this is clear. This concept, it has been it's a little confusing, but if the clear ஆயிருக்கும் நான் நம்புறேன். Okay, fine. This is my magnetic field inside the solenoid. Okay, இப்போது நான் வெளியே இருந்து if I have more field, இப்போ வந்து இங்கே 10 வந்து நான் கொடுத்துட்ருக்கேன், 10 வந்து வெளியே இருந்து எனக்கு வருது, and I develop 2 in magnitude. ஓகேவா? இது 10க்கு பதிலாக if there were 20 I would have developed 4, say 4. Okay, I would have developed 5 or 10 or 6 Tesla, so that the entire net away there is an increase. It will be 20 plus 6, 26 இருந்திருக்கும். கரெக்டாக? சே 10க்கு I had 2, 20க்கு I had 6, I had developed 6. Okay, fine. This, so can I say that my external internal field இருக்கு இல்லையா, I mean the how much I am getting magnetized is proportional to how much push I am getting from outside, how much magnetic field push I am getting from outside, right? Okay, so either in the proportionality நான் remove பண்ணும்போது I am adding a new term called as zeta. This is my magnetic susceptibility. So this is how much I got, this is how much this is how much I produced on my own, this is how much push I got, this is the push I got, this is how much I produced. Okay, it depends upon this zeta thing. This is called as my magnetic susceptibility. Fine. Okay, Okay, fine. So the magnetization, it depends upon material. Okay, material dependent, obviously. uh, if it were more na, for for the same, if I compare the magnetic susceptibility of two materials, one அதிகமா இருக்கு ஒன்னு கம்மியா இருக்குனா, for the same amount of push I'm getting, for the same amount of H, it's nothing but the magnetizing field. For the same amount of magnetizing field, the one with higher magnetic susceptibility will tend to produce more magnetic field on its own compared to that which has lesser. Okay, that's the basic concept of this. So magnetic susceptibility முடிஞ்சு. Properties of substances, I think I told you ferro magnetic substances, and the theory portion மட்டும் சின்னதா இருக்கும். Zeta value for paramagnetic, ferromagnetic and diamagnetic, it will change. Okay, it varies on few levels. I will teach that in the question solving session of this concept. Okay va, don't worry. So இதோட the terminologies understand பண்றது, it's important for me. I think I've done that well. If you have any doubts, you can, okay, you can always ask me, right? Okay, fine. Paramagnetic substances and diamagnetic substances. Diamagnetic substances na, whenever I have a substance, okay, diamagnetic substance இருக்கும்போது, when I put magnetic field inside, it gets decreased. Okay ba, so my zeta value is in negative. Okay, it develops magnetic field in the opposite direction. Okay, basically diamagnetic substances. Paramagnetic, it develops magnetic field in the direction of magnetic field. Okay, so it's positive. So zeta value is slightly negative for para. For dia, it's positive for paramagnetic substance. Okay, fine. Okay, you have any doubts? I want to get in. How can I if you get into MMC, you can, you could easily contact me. I'll be in college only. Or you can check out, hopefully you get into MMC. Yeah, fine. It's a good college. Okay, so properties of substances, I magnetic susceptibility சொல்லிட்டேன். magnetic, yeah, அதான் HI and zeta is over. Individually paramagnetic substances, diamagnetic substances and ferromagnetic substancesல zeta value எப்படி vary ஆகும் with temperature, அதெல்லாம் வந்து question solve பண்ணும்போது I'll tell you how it works. So அது வரைக்கும் let's not delay the class session. I think இதோட முடிச்சுட்டான்னு நினைக்கிறேன். I think it's fine so far, right? I think we'll finish it off. I have to leave for hostel as well. Yeah, இன்னைக்கு வந்து late ஆயிடுச்சு. I got stuck in traffic. Chennai traffic, bro. It's very bad. Fine. Okay, fine. All right, guys. Bye. See you in the next class. Anna, I'm a fresher. Drop எடுக்கிறது, it's not a waste. Okay, it's the time you give yourself to invest in yourself. Okay, it's the time which you take to invest in yourself, to have better understanding of whatever the concept is. So because in the exam, as I told you, it determines how your life is gonna go. for the next 5.5 years if you got it right, or else one more year drop எடுத்து திரும்ப if you crack it in the it changes your life for the next 5.5 years. அதுக்கப்புறம் you still have to prepare for another exam. அது வரைக்கும் this is how it goes. Okay, fine. Now ட்ராப் எடுக்கிறது வந்து ஃபார் ஃபியூ பீப்புள் இட் வில் பி லைக் ஒரு வருஷம் வேஸ்ட் பண்ணுறோம் பண்ணுறோன்ட்டு. But if this seat actually meant something for you, okay, if this medical profession actually meant something for you, you would definitely do it. இந்த ஒரு வாட்டி கிடைக்கலன்னா இன்னொரு வாட்டி நீங்கள் ட்ரை பண்ணுவீங்க. There are people who say drop is it's not worth it. ஆனால் if that's what you really want, okay, if that's what you really want, taking a drop is not a waste of time at all. Okay, fine. ஸ்டேட் போர்ட்னா ஸ்டூடெண்ட்னா ஸோ நீட் ரொம்ப கஷ்டமாக தோணுது. ஸ்டேட் போர்ட் ரொம்ப முடியாது. அதெல்லாம் பிரச்சனை இல்லை. சிபிஎஸ்சி போர்டாக இருந்தாலும் கிராக் பண்ண முடியாது தான். இட் ரெக்வயர்ஸ் a different step of approach for everything. நீங்கள் ஒரு போர்டு எக்ஸாமுக்கு ப்ரிப்பேர் பண்ணுறக்கும் நீட் ப்ரிப்பேர் பண்ணுறக்கும் தி அப்ரோச் இஸ் டிஃப்ரெண்ட். அது வந்து யூ வில் கெட் டு நோ as time progresses. ஓகே, ஃபைன். பட் ட்ராப் எடுக்கிறது இட்ஸ் நாட் அ வேஸ்ட் ஆஃப் டைம். இட்ஸ் த இன்வெஸ்ட்மெண்ட் யூ ஆர் புட்டிங் so that you will be better. I mean, you will get your dream college or medical seat. Okay, don't think it as a waste of time. And mari, if you had thoughts, if you yourself had thoughts na, that means this is not for you. Okay, that means you're not passionate about the medical profession at all. Okay, fine. 1 year drop, I think it's fine. 2-3 எல்லாம் போகும்போது you just know the course is already 5.5 years long, and then நீ பிஜி 3 வருஷம் பண்ணும், அதுக்கப்புறம் சூப்பர் ஸ்பெஷாலிட்டி பண்ணுறேன்னா அது இட் வில் டேக் another 2-3 years. ஃபைன், சம்டைம்ஸ் 5 years பண்ணணும் நியூரோ சர்ஜரிஸ் இருக்கும் இடத்துல. ஆர் எம்எல்இ பிளாப் போனீங்கன்னா அங்கே யூ ஹேவ் டு லேர்ன் அண்ட் எவ்ரி திங் என்டையர்லி நியூவா. Fine. So it's a very long learning curve for us. Okay, to have some amount of say to have settled to some level, it will take time. So 2-3 years of drop, I don't know, but 1 year for whatever, so for something you like, I think it's definitely worth it. Okay, bye. So இதோட கிளாஸ் முடிச்சுக்கலாம். Yeah, see you guys in the next class. Sunday I'll take 2 classes again, afternoon and evening. இதே மாதிரி I'll try to finish off those chapters கொஞ்சம் quick. Okay, fine, bye, see you.